let's talk about number 4. In number 4, what do we need in order to solve for x? Scale factor. Thank you, Samantha. So how do I find my scale factor?
Find the side measures of the sides.
Let's do number 4.
Oh.
We're on number 4. So in order to find my scale factor, I have to find two sides that we know the length of that are corresponding.
12 and 15.
12 and 15. Are we sure? Let's look at the two angles that are between 12. We've got this angle, which has 1 mark, and a 90-degree angle. Does 15 have the same angles that are next to it?
Oh.
No. Which other side has those two? 8. So 12 and 8 are corresponding. Before, guys, I can't stress this enough. Before we move on, establish which one you're going to use as the numerator and which one you're going to use as the denominator, okay? I'm going to use the larger one as the numerator and the smaller one as the denominator. If you just want to put an N and a D, that's fine, but you have to specify because there's too many mistakes where like you set it up one way and then you reverse it and you get the wrong answer, okay? So numerator and denominator, and that's going to hold for the rest of the problem, okay? So my fraction is going to be 12 over 8, okay? 12 is in the numerator, 8 is in the denominator. And we're going to set this equal to, well, before we create a proportion, let's simplify it. What does that simplify to? 3 over 2. We can divide both the top and the bottom by 4. Okay, now we have to set this equal to something involving x. What side is corresponding to x? Very good. 15. Why? You're absolutely right, Noah, but why is 15 the one that's corresponding to x?
Because they share the same angle.
Very good. The two angles are the 90 and the double one, right? Same thing for x. It's got the 90-degree angle on it, and it's got the double one, okay? That's always how you're going to identify which ones are going to be corresponding. It's easier when there's letters, right? Because you can just be like, oh, these two letters match up with our similarity statement, okay? But that's not always going to be the case. You're going to get examples like this where you have to look at the angles. All right, so we've got x and we've got 15. Which one goes in the numerator? X. Okay, you have to follow that same pattern. So x goes in the numerator, whoops, and 15 goes in the denominator. What do we do next? Cross multiply. So we multiply the 2 and the x and the 3 and the 15. We get 2x equals 45. And then what do I do? Divide by dos. And I get x equals 45 over 2 is 22.5 or 22.5. Or you could just leave it as 45 over 2. Either one is fine. But keep in mind, if this is like one of those problems where it's going to ask you for perimeter, you want to put it as a mixed number because it'll be easier when you add them all together. Okay? Questions on numero 4, number 4 on the warm-up. Okay, so you remember how yesterday we were doing all these problems, but we were told that the triangles were similar? Now we're going to have to prove that triangles are similar. And there's one super easy theorem that we're learning today, and it's the angle-angle theorem, okay? This is chapter 8, section 2, prove triangles similar by AA. Circle that AA and just write angle-angle, okay? Whenever you see AA today, doesn't stand for that. Doesn't stand for a AA battery, it stands for angle-angle. Angle-angle, okay? Whenever you see AA today, it stands for angle-angle. Okay. The angle-angle theorem, I guarantee all of us already know it. It's just put into words. If two angles of one triangle are congruent to two angles of a second triangle, then the two angles are similar, okay? Now that completely makes sense. Because if we know two angles of a triangle, how do we figure out the third one? If we know two angles of a triangle, how do we figure out the third one?
You add them all together and subtract from 360.
Very good. You subtract them from 180, right. We subtract them from 180. So if two of them are the same in two triangles, what do we know about that third angle of each triangle? It's also going to be the same. Very good. Because if you take whatever those two angles are and you take them away from 180, that's always going to be the same. Okay. So what I want you guys to do is just put a third congruence mark at C and F. Okay? So when we're working on these problems, guys, all we need to do is prove that two of the angles are congruent. Once we prove that two of the angles from each triangle are congruent, we can apply the AA similarity theorem.
Hold on, Mr.
Of course. Oof. All right, example 1, okay? That is all we are learning in this lesson. The rest of the time we're doing examples, okay? So in example 1, tell whether the triangles are similar or not. We're going to start with B. Are these similar? Yes, this is just picture perfect definition of the AA similarity theorem. So you can write AA similarity theorem and put yes. Okay? These are definitely similar. That's just picture perfect AA similarity theorem. We have two angles that match up, two angles that are congruent. Let's take a look at C. Now C is a little bit more difficult, okay? But I want you guys to think about the two triangles that are right next to each other. So this one and this one.
Yeah.
I would agree, they are definitely similar, but in order to prove that, we have to find an angle that's congruent. Two angles that are congruent.
Right there at the top.
Okay, yep, right there at the top. Well, we need another set, okay? Between each triangle, we need two.
The ones at the bottom,
Why?
because the lines are like touching, so they're the same.
They're congruent sides.
So it's not this one. Oops. It's not this one. These two we don't know to be congruent.
It's the one across from them.
Why?
Because the sides are the sides on the
So Marcos brings up a good point. It's these because the sides opposite them are the same length. Imagine that this is a huge triangle, right? What kind of triangle is this? Isosceles, right? Wouldn't those two angles at the bottom be our base angles? And wouldn't they have to be congruent? Okay? Some of these pictures, guys, you're going to have to look at it from a different angle, okay? So since we have two sets of parallel or congruent angles, this is AA similarity theorem. And yes, similar. Let's move on to D. Okay, now D is a little hard to see. So I'm going to highlight the two figures for us. Here's one triangle.
The other can be a triangle.
I know, it looks like it's a quadrilateral, but this is our second triangle. Do you see it now? Okay, so we're told, we're already given one angle, one set of angles that are congruent. What's the other set? When you see it, you're going to be like, oh my gosh. Which one? What do you mean the one right there? Which end, the left end or the right end? On the left side or the right side? Because there's an angle here and there's also an angle here.
The left side.
Why? Why is this one?
They're both like overlapping.
Very good. They both share that point, right? They both share that vertex. Whenever two of the triangles share a vertex, that is always going to be an angle, okay? That's always going to be an angle that you can use for your congruence. So this one is yes. Same thing, angle, similarity. I'm just going to put SIM theorem. Okay? Angle, similarity theorem. And it's because we noticed that that last corner was part of both triangles, okay? That last corner was part of both triangles. Okay, now we're going to go to A. A is tricky, okay? Let's highlight first the two triangles. Here's our smaller one. And here's our bigger one. They don't give us anything other than that these two sides are parallel. We need to come up with two angles to prove that they're similar.
Since they're sharing a side, wouldn't their base angles be equal? Since it's a split triangle, wouldn't their base angles be equal?
Because they're parallel, yes, okay? We'll get to that one. What's the most obvious one though? The most obvious angle?
On the tip.
The one at the top, right?
Top one.
The one at the top, the one at the tip. So this one is shared by both triangles. Do you guys agree with that?
Yeah.
That corner is the same. Now, why is this angle congruent to this one?
Because they're
The
parallel.
triangles are parallel.
Yes, it has to do with the fact that these two lines are parallel. But what's the relationship between those two angles? You're going to have to think back, dig deep into your geometry brain, into your geometry files. What's the relationship between those two angles?
Does that have like anything to do like with our very early lesson, like with like consecutive interior angles?
Yeah, but these are not consecutive interior. What's the name of these two angles? They're not adjacent. They're not opposite.
Consecutive?
Nope. These are what we call corresponding angles, okay? Do you remember how if it was like top left and top left, corresponding, top right or top right? So I want you guys to write that down. These are corresponding angles, okay? And if you want to star this problem, we're going to see this one a lot, okay? Where we're given two sides and they're going to be parallel, and then we're automatically going to know something about their angles, okay? So once we have both the angles, we know that this is angle, similarity theorem. And yes, they are similar. Goodness. Yes, they are similar. Beautiful. Ooh. Okay, next slide. Example 2. Find x, okay? And it's kind of hard to see, but these two lines are parallel, okay? If you want to write it more larger, please be my guest, just so you can see it. Those two lines are parallel. And so let's go ahead and highlight our triangles. Are these going to be similar?
Yeah.
Yeah. Why?
Because the top corner
Yep.
and the bottom right corner are both.
Good. The top corner and this bottom right corner. Or you could have picked this one, okay? It doesn't matter. But we know that all their angles are the same, okay? So we can apply, say that yes, these are similar. So if they're similar, okay, we need to find a scale factor to find x. What's up, Samantha? Yeah. We need to find our scale factor to find x. How are we going to find our scale factor?
Can we do a 3 over 1?
It's not going to be 3 over 1. I agree, we need to use the 3, right? Because that's the one side of the smaller triangle. But what's the size of the larger triangle, that same side?
4.
It's 4, okay? We have to add these two together. Because the larger side is this whole thing, right? So we have to add the 3 and the 1 together. And that corresponds with the side that's just 3, okay? You with me? Okay, so our first one, let's make this the numerator. Let's make the larger one the denominator. So our first fraction is going to be 3 over 4. Or 3 over 3 plus 1. Which is 3 over 4. This is our scale factor. Okay? Now we have to set that scale factor equal to something involving x. Okay? So this 3 over 4 is going to be equal to, what can we write as a fraction that involves x? 5 over, but it's not just x. 5 in my numerator, what goes in my denominator? It's not just x.
5 plus x.
There we go, Juliana. It's 5 plus x. Very good. Okay? Do you see how this whole side is the larger triangle? You have to add the two lengths together. What do we do now? Yep, we cross multiply. So we're going to take the 3, multiply it by the 5 plus x, and the 4 and multiply it by the 5. What am I going to get? Remember, we're multiplying. So this is 3 times 5 plus x, yep, equals, and then 4 times 5 is just going to be 20, okay? So then, yep, you said 15 plus what? 3x equals 20. We can subtract 15 from both sides. We're going to get 3x equals 5, and then divide by 3. So x equals 5 over 3. Yeah, you could do 1 2/3. Okay. Example 3. All right, we have to write first a similarity statement involving ABC and the other triangle. Remember, the order matters. What triangle is similar to ABC?
EBD?
EBD. And in B, it wants us to solve for Y. Before we solve for Y, what do we need?
Scale factor.
Scale factor. How are we going to find the scale factor?
CD over DB.
Ah, very good. CD over BD, but not quite. It's going to be CB over DB.
Oh, yeah.
Do you see that? It has to be the whole side over the smaller side, okay? So if we make this one our denominator and this one our numerator, okay? Our smaller one's going to be our numerator. Sorry, did I mix that up? I did. It's going to be the larger one is going to be our numerator, and the smaller one will be our denominator. We have to keep that ratio the entire time during this problem, okay? So CB over DB is going to be, what's CB?
7.
7. What's DB? 4. Good. So our scale factor is 7 over 4.
Yeah.
How are we going to use that to find Y?
Cross multiply that with y over 8.
Mm-hmm. No, it's not Y over 8.
8 over y.
8 over Y. Notice, numerator, denominator, okay? Anything from the small triangle will be in the denominator. Anything from the large triangle will be in the numerator, okay? Now we cross multiply. We're going to get 7y equals 32. We just divide by 7 to both sides, and we're going to get y equals 32 over 7, or 4 4/8. Okay. BE divided by BA. What's BE? 3. What's BA?
3 plus x.
3 plus x. Okay? Now, someone tell me, be very careful here, why can't I use that and set it equal to my scale factor? 7 over 4. Why can't I do that? I can do it if something was changed, but the way that this is set up right now, something's wrong. Very good. The BE, right, is from the smaller triangle. And we wrote in the beginning that has to be in the denominator. Is BE in the denominator? No, it's in the numerator. So this is wrong, okay? Do not write it like this. You're going to have to flip it and write 3 plus x over 3 equals 7 over 4, okay? Make sure you stay consistent with your numerators and denominators when you're creating these proportions. Okay, now we cross multiply. We're going to get 21 equals 12 plus 4x. We subtract 12 from both sides. We get 9 equals 4x. Divide by 4 to both sides. And we're going to get 9 over 4, or 2 1/4 equals x. And we're done. Okay, people, last example. Given AC is parallel to BD, prove that AOC is similar to BOD.
You didn't have time for me.
Yep, positive. So we're proving that these are similar. What do we need to prove similarity? Think about the theorem we learned today. What? 2 angles. Very good. Very good. Do we see an angle that is going to be congruent between the 2 triangles? Go ahead, Marcos.
Oh,
I'm going to lose it. There's no angle O here, people.
wait, no, the angles at the sides.
Yes, but tell me, you got to be specific. Angle O does not exist. Angle O is not an angle. O is a point.
A and B.
What's that?
A and B.
A and B. Why? Okay.
Since they're both parallel, that would mean they're...
Okay, so you're talking about these 2 parallel lines. Good. What's A and B's relationship?
They're parallel to each other. It's just...
Yeah, but they're angles. The angles. What's the relationship between the angles? What's that? They're not corresponding.
Interior?
What's that?
Alternate interior?
Very good. Alternate interior.
I was gonna say...
Alternate interior. Now, you said angle O. You're on the right track. I just got very angry because angle O is not an angle, and I see that still so often. But what about the point O is going to be congruent? Be specific with which angles we mentioned. So we said angle A is congruent to angle B. Alternate interior. What else? Come on, guys. Once you see it, you're going to be like, oh my gosh, how did I not see that before?
You still use
Angle D congruent to angle C.
like BOD.
Yeah, you could say D and C, okay? But there's one that's super obvious.
Isn't O like congruent to itself because they're vertical?
Please don't call it
Not that
angle.
it's an angle, but like the angles that are right under it.
Yes, but be specific. Use 3 letters.
AOC and DOB.
Thank you. AOC and DOB. Okay? If you guys are still calling it angle O, you're going to drive me crazy. Okay? Angle O could be so many different things. You got to be specific. Okay? So AOC is congruent to angle DOB.